Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Daniel bin Muhammad Sahid, and today my team and I are going to present about our CSC645 group project titled Shortest Path for Vehicle Routing using Dijkstra algorithms.
Before we begin, I would like to introduce our team member. Firstly, Muhammad Daniel bin Muhammad Sahid, act as our project manager. Next, Muhammad Daniel Hakimi bin Muhammad Yazid, which is our programmer. Next, Masara Yasmin binti Ishaq, which is our algorithm designer. Next, Nur Farah Ain Aliyah binti Imran, which is our documentation manager. And the last one is Nur Shakila Ashiki binti Hassan, which is our testing and presentation manager.
Route selection is very important in a daily life because people need to travel efficiently by choosing the shortest path with the minimum distance. Therefore, this project aims to build a simple system that can compute and visualize the shortest route within two selected points among multiple possible paths.
The objective of this project are to implement Dijkstra algorithm for solving vehicle route optimization problems, to apply the algorithm in determining optimal vehicle paths, and to evaluate algorithm's effectiveness through route result and visualization. The scope is to find the shortest path within a chosen point, where the distance must be positive numbers only. The system can only visualize the road added and highlights the shortest route in the graph diagram, and no databases or store sessions required.
Have you ever wondered why most drivers tend to choose the same routes every day? The main reason is that many road users do not know which route can actually provide the shortest or most efficient path to their destination. When multiple routes are available, identifying the optimal one becomes difficult. Manually comparing several routes with different distances and travel times is not only challenging, but also time-consuming. As a result, drivers often rely on familiar routes. Due to this behavior, a large number of vehicles end up using the same main roads, leading to traffic congestion, while other potential routes remain underutilized. This situation supports the statement by Muda in 2024, which highlight that traffic congestion has become a national issue in Malaysia, especially in major urban areas such as Kuala Lumpur and Johor Bahru.
The proposed solution for this problem is by using a greedy approach based on Dijkstra algorithm, which select the shortest path at each step. This is the flow of the proposed system. First, the user need to build a new road or path. Then they need to set the starting locations and the destinations. Compare all of the possible connected paths. After that, it will select the shortest available path step by step. This will be keep or repeat until it reach the destinations, and then at the end of this, the system will display the final shortest route and distance. Dijkstra algorithm being selected because it's suitable for finding the shortest path using a greedy approach that selects the minimum distance at each step. It is efficient because it does not calculate all of the possible paths, which save time and computational. The algorithms also guarantee the shortest path, making it ideal for the routing planning. Compared to the minimum spanning tree, brute force methods, Dijkstra algorithm is more appropriate because MST does not focus on the specific destinations and brute force is inefficiency.
First, we define the algorithm function. Then we create a priority queue because we use a min heap to make sure the algorithm always choose the nearest unvisited nodes. And this is to store the visited location in a stack. And then we also use a while loop, and this is to extract the nodes with the smallest distance from the priority queue. If the node has been stored in the visited set, it will be skipped. But if not, we are going to add the nodes in the visited set. Then we update the path by adding the current nodes. And this is to check whether the destination has been reached or not. If yes, the algorithm will stop immediately and return the shortest distance and path. This part is for checking all the neighboring location of the current node and their distance. The algorithm will ignore the neighbors that has already been visited, and for each valid neighbor, it will update the total distance and add it to the priority queue. This will ensure the shortest route is always explored first. If the destination is reached, the shortest distance and path will be returned, but if no route exists, the algorithm will return infinity and empty paths. And the rest of the code is more to visualization.
This is a question from tutorial. We have to calculate the shortest path using Dijkstra algorithm. We have to list out all the inputs and weight. It has from location to location, distance, submit road, and visualize current network. So we input all the nodes and the distance in km. And it will have the added road, current road network. And we proceed to input all the nodes here. Okay, now we have all the current road nodes, and this is the graph visualization. We can choose the source and destination, and then we can compute the shortest path. Lastly, this is the answer if we calculate manually. For the conclusion, we implement Dijkstra algorithm to determine the shortest path. It is also allow user to visualize the road, and it has real-life applications. For future improvement, including real-time traffic data, it is to enhance the system usability and effectiveness. Thank you.